Hi everyone, my name is Erin Boettcher and I'm a postdoc at the University of Chicago. I'd like to share with you a recent result showing the discovery of what are likely circumgalactic molecules associated with a massive early type galaxy. This work is done as part of the Cosmic Ultraviolet Baryon Survey with this great team of collaborators shown here. CUDThe is a large Hubble program that obtained cross spectroscopy of 15 quasars, selected to probe the intermediate redshift CGM with an accompanying deep galaxy redshift survey. For more information about CUDThe, I encourage you to see Chen et al. 2020 and Xiaowen Chen's keynote talk from the first week of this program. Here I'll discuss a case study of a damped Lyman alpha absorber detected in CUDThe at a redshift of 0.576 that has a neutral hydrogen column density of about 20.1. We see in ground-based shell spectroscopy that the accompanying metal lines are resolved into at least 10 velocity components with a dispersion of about 70 kilometers per second. We find that the DLA is accompanied by absorption from the Lyman and Werner band transitions of molecular hydrogen. On the right, I'm showing several examples of these transitions from different lower rotational states, where you can see that there are at least 2 velocity components present in the H2 that are separated by about 60 kilometers per second for a total H2 column density of 19, or a molecular fraction of about 12%. We find that the metallicity of the absorber is about 40% solar from O1 absorption. Additionally, at the upper left, we see that the velocity integrated abundance departs most significantly from solar for the most refractory elements, suggesting significant dust depletion. Below that, we see that while there is some component-to-component variation in the chemical abundance pattern, we find that all components are consistent with subsolar magnesium to iron ratios. At right, we see that once these ratios are corrected for dust depletion, there's evidence for substantial iron enhancement from a significant contribution from type 1a supernovae to the chemical enrichment history. When we look to the galaxy redshift survey, the system becomes especially interesting. We see an overdensity of 9 galaxies within 300 kilometers per second and 600 kiloparsecs projected distance from the absorber. The galaxy at the closest impact parameter is at about 40 kiloparsecs, and it's a massive early type galaxy with no detectable sign of star formation. You can see its spectrum at the upper right. The chemical abundance pattern supports the association of the iron-enhanced absorber with this quiescent system, which is over 3 times closer to the sight line than the next closest known galaxy. The system represents a likely example of circumgalactic molecules, where the H2 is associated with the CGM or possibly the extended ISM of the quiescent galaxy. The H2 may arise from a variety of mechanisms, including a possible past epoch of AGN activity or galaxy interactions in a group environment. Although it's possible that the gas arises from a galaxy that's hidden by the light of the quasar, we can place an upper limit on the star formation rate along the line of sight of less than 0.1 solar masses per year. So this system illustrates the power of pairing deep galaxy redshift surveys with absorption-line spectroscopy to uncover circumgalactic molecules which are often below detection thresholds for other methods at the low column densities likely associated with the CGM. I'd love to talk more about this work with anyone who's interested, and you can find the paper at the archive link shown here. I'd also like to encourage you to talk with Fari Zahedi about his 2020 paper on another H2-bearing DLA associated with the quiescent galaxy. Thank you.